Once again, I don't know how you do this without using a calculator unless you do have a right triangle. So the law of sines and the law of cosines can be used on right triangles, but are the only things that can be used if you don't have a right triangle. To help explain this one, what I'm going to do is use this as a right triangle. And keep in mind for this one, as we look at this one, I got my little thought bubble again. We know that special triangle, if you have a 30, 60, 90 triangle, it's in that ratio of 1, radical 3, and 2. So if I know that this has a length of 3, then I know that across my 60-degree angle has to be 3 radical 3. And this is the hypotenuse is 2n, so 2 times 3, which would be 6. So I know that x has a value of 3 radical 3. But say we don't recognize that special triangle, and we don't know, we don't have a pair. I don't know 2 of the angles, so I can't find another angle so that I have pairs to work with the law of sines. So what we're going to have to use is you have to use the law. I'm going to stand this up. The law of cosines. So the law of cosines, I don't know how they give it to you. They probably told you is a squared equals b squared plus c squared. Oh, look right there. That looks like the Pythagorean theorem. Minus 2, and then you're going to use the 2 sides that you have on the right-hand side. So it's going to be that the sum of the squares, those 2 sides. So it's going to be 2bc, and then you're going to take that times the cosine of angle A. Now, something to keep in mind when you're dealing with the law of cosines. This first value, which is A, the ending point will be the side opposite. So you will always have your pair opposite, like starting and ending in the law of cosines. Now, if we're looking for A, to get rid of what we have, I mean, if I want to solve just for A, as a final step, you want to get rid of that square and take the square root. So I'm going to use the law of cosines to find the angle or the side length of x, which I already know should have that value of 3 radical 3. Here's how the law of cosines works. So I am looking for x, and the side opposite of that happens to be, or the angle opposite of that happens to be 60 degrees. So that's the pair I'm working with. So I'm going to say x squared, that's what I start with. I start with the side, I end with the angle. X squared is equal to 3 squared plus 6 squared minus 2 times the product of those 2 angles. So I have 3 and 6. And then the cosine of the angle opposite of the very first value I started with, which is 60 degrees. Now I know that to get rid of the square, if I get rid of the square, I'm going to have to take the square root of that value. So let's calculate that. X is equal to the square root of 3 squared is 9, 6 squared is 36, minus 2 times 3 times 6 is going to give you 36. And then the cosine of 60 degrees using your finger trick, hold in your pointer finger, and the cosine of that is 1/2. So if we continue to calculate, I'm going to have x squared is equal to the square root of 9 plus 36, and half of 36 is going to be minus 18. So I look at it as 36 minus 18 is 18 plus 9 is 27. So this is equal to the square root of 27. And if you simplify that, that is 3 times 3 times 3, or 9 times 3. That pair of 3's can come out, and you find out that x is equal to 3 radical 3. And that is what you are looking for. We know that's what the value is going to be because I know it's a special triangle. It's a 30, 60, 90 triangle. Okay, I'm going to pause this for a second. When I come back, I will have another screen up looking for maybe a side length. and how you use the law of sines, or maybe looking for an angle and how you use the law of sines to help you with that. Okay, so I hope this works because I just tried to go back to that reference triangle. I'm going to put that thought over here. So my thought bubble says, okay, I know of a special triangle, which is a 30, 60, 90 triangle, and it's in that ratio of 1 radical 3 to 2. So what I have here is I have this side length here being 3. So this has to be 3 radical 3. And 3 times 2 makes that hypotenuse 6. So the side lengths I have, and I realized that when I solve, my answer should be 30 degrees. Now I know that because I'm using the special triangles. If you were using something that involved a 70-degree angle or a 40-degree angle, you can't use that special triangle, and I would think they would have to let you use a calculator on that. But this is going to give you the general idea of the process of solving the law of sines when you are looking for an angle measure. We don't have any angle, can't use the law of sines, so we're going to use the law of cosines. Start with one of your angles or your side. Remember what you start with. What you start with, you have to end with the angle opposite of that. So since I want to end with x, the side opposite of that is 3. So I want to start with that value of 3. Because your pair has to be the beginning and the end of it. So a squared is equal to b squared, I don't care which one you let be b, plus c squared minus 2 times a times b times c. So let me change that here. I thought I hit my arrow back to undo that part, but maybe not. Okay, I erased a lot. So plus 6 squared minus 2 times 3 radical 3 times 6, those 2 side lengths, and then you're going to have the cosine of x. So since you're looking for an angle, you are going to have to use the inverse in order to solve. So let's start solving using our algebraic concepts. You know, 3 squared is 9. 3 radical 3 squared, you're taking 3 radical 3 times 3 radical 3. So you're going to multiply the numbers in front together. You multiply the radicands together, which is going to be the square root of 9, or it's just a value of 3. And that gives you 27. So 3 radical 3 squared is 27. 6 squared is 36. Minus, you're going to have 2 times 3 is 6 times this 6 is going to make it 36 radical 3. And then you have the cosine of x. So as you're solving for an angle, you want to isolate that cosine x term. So we want to isolate this term. So we can group our 27 and 36 together. So 9 is equal to 63, I believe, when you add those together, 15 and 13. 63 minus 36 radical 3, the cosine of x. Now I still want to isolate that term, so I'm going to move the 63 over to the other side by subtracting that 63. So if you take 63 and you subtract 9, you're going to end up with 54, and it's going to be negative in this case because you are subtracting the 63 from it. Let me slide this. So you get negative 54 is equal to negative 36 radical 3, the cosine of x. Now still want to, I've isolated that cosine term now, but I want to solve for x. So I want to isolate the cosine of x. So to do that, what we're going to have to do is we need to divide by negative 36 radical 3. So if you divide by negative 36 radical 3, I am going to rationalize that denominator. So if I rationalize the denominator, I'm going to multiply by radical 3. So you get a negative over a negative is a positive. So we're going to end up with 54 radical 3 over, do this, radical 3 times radical 3 is 3. So you're going to end up with, I don't know, I would probably write it as just 36 times 3. I mean, if you want, you could do something different, but I'm going to leave it as that because we need to reduce that anyway. So if you took your 36 times 3, you would have 108. And like I said, I think it's, well, I don't know, you could do that because if I wrote it as 54 radical 3 over 108, you see that 54 goes into 108 2 times. So you are left with radical 3 over 2. Now that's just for that right-hand side. Maybe I should write that underneath. So as you simplify that, you get radical 3 over 2. And on the right-hand side, when those negative 36 radical 3 cancel, you are left with the cosine of x. So what this is saying, another way to ask this question right here, it's saying the cosine of what angle is equal to radical 3 over 2. That's the same thing as saying the inverse of the inverse cosine of radical 3 over 2. So if you resort back to your finger trick again, oh, fat hand again here. Okay, so here's your 2. You want cosine, which is the top, so you want radical 3 over 2. So you fold in that ring finger, and if you fold in that ring finger, that's 30 degrees. So your answer becomes 30 degrees. Now, if you go back up here to the top, we said that's what we knew the answer was going to be because I made it that special triangle. So that's how you're going to use the law of cosines when you're looking for a side or an angle. Just please, please, please make sure when you do that, that your pair, one of those 2 blue regions that I just highlighted, has to be your unknown value. One of those 2 blue regions has to be your unknown value. Okay, I hope this helps. Let me know if you have other questions or other examples you need.